So this is a guided walkthrough for the infected machine from the VulNyx platform. All right, let's get started. So the first thing we like to do when we do these CTF box challenges is we like to run an nmap scan. And nmap is a tool that is going to let you know what networking ports are open on a particular server. So it's going to be 10.0.2.81. Okay. So of course, when we run nmap, we have to run it with a bunch of different arguments in order to get different results from the program. So we're going to run it against all ports with this argument here, -p-. We're going to run it with 4 threads with this option, -t4, which means it runs fast but not too fast. We run it with very verbose output here, -vv, which means we will get output from the program before the scan is done. And we're going to scan and use scripts on whatever services we find with -s_C and get versioning information for the services with -S_V. So let's run the scan. And we see here that we pick up on 2 different ports. There's port 80 and port 22. So we're going to know in just a second what services are running on these ports. So nmap reports that on port 22, an SSH service is running, and it is running OpenSSH software with version 9.2. We also see that on port 80, it's running an HTTP server, which means this is a web server with Apache software, version 2.4.57. Okay, so the next thing we need to do is we need to do some enumeration on port 80 over here. So there are several different tools that we can do to enumerate web ports. And the first one we're going to do is we're going to do Nikto. So Nikto is a web app application vulnerability scanner. Web app vulnerability scanner, rather. So it's going to be able to pick up on any low-hanging fruit vulnerabilities that might exist on the system. It's a rather old tool, but I like using it because the syntax is very easy to remember. Okay, so while this is running, I'm going to also run another. So I'm going to run another web app enumeration tool, and that's called dirb. And dirb is going to run a very quick directory busting attempt on the server. And directory busting means we're going to try to find out what endpoints exist on the server by fuzzing them. Dirb actually uses a very small but a very small and kind of outdated word list, but sometimes it can get some good hits. So we actually see here that there's an info.php page available. So info.php is a page that exists sometimes on PHP servers, and it can actually tell us a lot of information about the web application. So let's talk a little bit more about this. Okay, so PHP Info Output. So like I said, it looks like this web application is running PHP, and in a PHP software environment, the PHP info function is used to output detailed info about the PHP environment, configuration settings, installed modules, and more. If PHP info output can be accessed on the web app, it could point malicious users to important configuration info, loaded modules, username info, and more. So what we're going to see from this particular web app is that in this case, the PHP output for loaded modules indicates that there is a mod_backdoor module loaded, which is unusual to say the least. Okay, so let's check this out ourselves. So over on our web browser, we can just navigate to the page manually, and then we can navigate to the info.php endpoint. So this is what it looks like when we have PHP info output on a web page, and we see that it actually tells us a lot of information. So for example, we can see some different web folders in here and file locations. we can also see that there is a user name that is exposed right here. This is a typical web app user on a Linux system over here. We've got server administrator email information, but what we're looking at in this case is the loaded modules over here. So, so there are all sorts of modules loaded up on the system, and if you're not paying very much attention, you're going to miss this. But there's something called the mod backdoor module over here. So this is unusual, and a backdoor is something that refers to how malicious users can gain access to a system. We can do a little Google search on this. So we can just search for mod underscore backdoor, and I'm going to look on GitHub to see if there's a GitHub repository associated with this. And we're actually looking for this particular backdoor right here. So from this user Wang Yihang, okay? So Apache HTTP server module backdoor. Let's take a look at this GitHub repository here. So what's interesting about this particular backdoor here is that it's the code is and it's the way it's used is explained in this exploit.py file. So let's take a look inside. And what we're looking for is defined in this first function here. So the exploit is the exploit is called exploit. So it takes host, port, and command as arguments. So in headers, backdoor, command. So how this backdoor works is that we actually need to send a web request to this particular server, and we need to include this backdoor HTTP header. And in the header, we can give a command, and in the output, it's going to give us the results of that command. So let's try this out. Okay, so what we're going to do is we're going to do curl, and we're going to curl to the to this website. Let's go over to the info.php endpoint, and what we're going to also do is we're going to provide a custom header, and the header that we're going to supply is, I think it was called backdoor, and then colon and then command. Okay, so it's going to be backdoor colon command. So I'm going to do who am I over here, and it should tell us that we're acting as the www data user. So let's send this off. Okay, so we sent our web request with the custom header backdoor with the command who am I, and we see that we are www data. Okay, great. So that means we have remote command execution on the target. So of course, what we're going to do is we're going to try to get a reverse shell on the target. So in order to get a reverse shell on the target, we first have to set up a netcat listener, and I'm going to set up a netcat listener over here on port 443. That's my favorite port to do reverse shell listeners on. After that, we're going to go back to the curl command over here, and we're going to craft a reverse shell command over here. So the backdoor HTTP header, we're going to use my favorite reverse shell command, and my favorite reverse shell command is the netcat named pipes reverse shell. Okay, so over here, I'm just going to copy this one over here, copy it, and then I'm going to go back and I'm going to paste in the reverse shell here. And the reverse shell, I need to fix some parts of this reverse shell. So first of all, I need to edit the port. So this portion over here is going to specify the port to be contacted. And we also need to put in our IP address. So in here, this is the IP address for my attacking system. So we recently discovered that there is a backdoor in this header over here that that was left by some hacker, some nefarious person, and we can actually activate system commands by using this custom header over here called backdoor when we do a web request to any page on the system. So we see here that we've created our reverse shell command over here. This is the netcat named pipe reverse shell, which I like to use, and we've got it all set up. All we need to do is give the command, and we should get a reverse shell. So let's do that. It says bad request. Okay, so I think it might be because the backdoor contains special characters. Okay, so what I'm going to do is, I think I've got to use a much simpler reverse shell. Maybe I can find an easy one on RevShells. RevShells.com. So RevShells.com, we're going to do 4443. I'm going to do IP address 10.0.2.22. And I need to make sure that my IP address is the same. So it is 10.0.2.22. Okay, great. Okay, so let's try a Linux one. So I just need OS equals Linux. And let's try the BusyBox one. So this one actually doesn't have very many special characters. So this one might go through. So I'm just going to copy this command here and then go back. And I'm going to edit the backdoor. And insert the BusyBox netcat command. Okay, so let's see if this one works. All right, so it looks like this one is working because we didn't complete the request, which means that it got stuck. If we go over to our listener over here, it says we've received a connection. So if we ask who we are, it says we're www.data, which means that we're in. Okay, so that means we have to put on our scary hacker voice guy and then do a little bit. Just a second. Hey everybody, it's the scary hacker voice guy. The scary hacker voice guy comes out whenever we break into a server. It looks like you were pwned by a hacker before and they left a back door. Well, you didn't find the back door and we were able to follow the hacker back in. Maybe you knew about this, or maybe you decided to accept the risk. You accepted the risk, and now, now we're in. All right, so we're in. All right, so we currently have a dumb shell right now. So the netcat shell is not very good. So what we want to do is we want to upgrade our shell completely. And because we started our netcat shell with bash, and inside of bash shell, we can upgrade it completely. What we're going to do is we're going to do this. First of all, we're going to figure out if we can upgrade our shell partially using Python. So Python is on the server, so we're going to do this Python command to partially upgrade our shell. So import pty .spawn bin bash. Okay, so now our shell is partially upgraded. To upgrade it fully, we need to do the following. So we're going to background the shell with Control Z, and then we're going to do STTY-A to get our terminal settings. Okay, we've got rows 27 and columns 111. We're going to be using these to upgrade our shell. Next, we're going to do stty raw minus echo, and then we're going to type in FG. We're not gonna see the letters FG, but we need to type FG and hit enter to foreground our shell. Back to the netcat listener, to the netcat shell rather, and then we need to do echo shell equals bash, and then echo term equals xterm dash 256 color, and then we need to do stty rows 27, columns 111. After we do that, we can clear the screen. Oh, it says term environment variable not set. Okay, so export shell equals bash, and export term equals xterm 256 color, and then I can do clear. Okay, great. So now my shell is fully upgraded. But now we have tab autocomplete, and now we have command history, and now we have terminal text editors. So we can just do nano, and we can, yep, okay, so now we're ready to rock and roll. Okay. So the first thing we want to do is we want to figure out if we have any special sudo permissions on the system. So it's a bit unrealistic that the www data user has any sudo permissions, but just bear in mind that these are educational exercises. So if we do sudo l, it says that www data may run the following commands unaffected. So as the Laurent user, we can run with no password user sbin service. So let's learn a little bit more about this command over here. So we're doing privilege escalation sudo service. The Linux service program is used to manage and interact with system services. It acts as a wrapper for starting, stopping, restarting, and checking the status of services. So if you wanted to start up your Apache server, you could use this command over here, service apache2 start. But if we have sudo access with the service binary here, we can do some privilege escalation. If we have sudo access with the service program, we can escalate our privileges by using a command similar to the above. So sudo service, and then we can back out of the service directory 2 levels, and then access the bin sh binary, and that's going to start up a an sh shell. So because the service binary is running with sudo, it's going to be running as a elevated user. So let's do that. So it's going to be sudo service. Oh, so in this case, we can run it as the Laurent user. So we have to do sudo u Laurent, and it's going to be service // bin bash. And now we're acting as the Laurent user. Who am I? We've got a shell. It's a bash shell. We're the Laurent user. So we're going to repeat this one more time. Now that we're the Laurent user, we're going to figure out if the Laurent user has any special sudo permissions. So it says here, user Laurent may run the following commands uninfected. As root, with no password, you can run user bin joe. So what is this joe program? I actually didn't know what this joe program was, but I did a little bit of research, and this is what it is. So the joe program is a terminal text editor, and it's considered to be more complex and feature-rich than the nano text editor. So if we think of the nano text editor as being super easy and super simple, and the Vim text editor as super feature-rich and super complicated, the joe text editor is somewhere in the middle of those. So the joe editor can run commands during program execution, And we can elevate our privileges if we can run the program as sudo by using the Control-K keyboard shortcut, followed by exclamation point, and then bin bash. So we can run programs while we're running the Joe terminal text editor. So let's do that. So we're going to do sudo Joe. So now that we're in sudo Joe, we can use the Control-K keyboard shortcut to give commands. So after we do Control-K, we do exclamation point, and then we can run a program. So program to run is going to be /bin/bash. Hit enter, and it says we are root at infected. So we've essentially compromised the system and become root because of the Joe program. All right. So now that we're root, we can do this.
What are you? I'm system root.
Okay, great. So we're almost finished today's exercise. All we need to do now is we need to get the root flag. So in order to get the root flag on this CTF exercise, we need to enter the root directory, and then we need to read this root.txt file. But we're not going to read the root.txt file in the traditional way, because the organizers at the VulNyx platform have requested that people doing walkthroughs and videos and write-ups on their machines not reveal the flag contents for any of their machines. So what we're going to do is we're going to read root.txt, and we're going to redirect the output into a file called iReadRoot.txt. After we do that, we're going to use md5 sum on root.txt and iReadRoot.txt. And we see that these two files have the same file hash, which proves that we were able to access the root.txt file and create a copy of it. All right, so that means we've read the root.txt file and we're done. Thank you very much for watching this guided walkthrough of the infected machine from the VulNyx platform. Thank you very much, and if you enjoyed the video, please click on like and subscribe. But until next time, HackerFrogs out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.